Thank you, Keres. Hi, everyone. Thank you first of all, for being here so late. I am joining from North Carolina. I am based in Raleigh, and it's 7:20 p.m. now. So I hope this is going to be the last session for today. So I hope that it will be not too long and informative, but also enjoyable. That it's my goal. So let's go ahead and jump on what we are going to see today. So what you can expect, it's going to be divided into three main things. I'm going to start with a short introduction to the ModelOps topic, or also MLOps topic. A little bit about, highlight some of the challenges we usually see when we work with customers. Then the major part of the session, I'm going to present a use case by showing a real life use case of how we can approach ModelOps in action. It's going to be pretty technical. It's going to be a lot of code. We're going to talk about containers. We're going to spin up containers, but nothing too long, just about 10 minutes. So just to give you a sort of a taste of what it looks like kind of behind the scenes when we talk about, okay, ModelOps, what are some of the things that we need to do? Give you some examples. And then finally, I will share some recommendations on best practices that it's good to adopt when, if you're starting, or if you're thinking to start, or if you've already started with ModelOps. So when we think about analytics, how analytics can support us to enhance and improve business decisions, because at the end of the day, that's what it all is about, we usually tend to focus mainly on the model development part of the work. And it's understandable, of course, because that is the creative part and also the fun part for most of data scientists. I speak for myself as well. However, if we take one step back and look at the whole picture, we might be surprised to understand that model development is only the very, very small piece of the puzzle. It's actually a team sport. Many people in different roles need to collaborate before a model finally runs in production environment and before it starts to return value. So, and this already highlights one important key element of ModelOps. It's not purely a technical concept, but also requires the right cultural and organizational setup to let all these roles contribute in an efficient way. And in fact, switching the focus a bit from people to a broader perspective, there are actually 4 components that are involved when it comes to ModelOps. We also have, in addition to people, we also have data, we have process, and we have the technology side. And each of these 4 aspects have their own priorities and challenges. What this highlights is that running a model in a real world production environment comes with a lot of dependencies. Additional work like data prep, operational topics, infrastructure maintenance are included, and the complexity of an ecosystem like this can easily be overwhelming. While there is probably not an easy way out, there are at least 2 powerful concepts to help you, and I would like to keep you in mind these 2 concepts because we are going to see them in action in a little bit. I'm talking about automation and testing. These are 2 additional key elements of the ModelOps approach. So in this session, I want to focus on these topics. What does it take to successfully operationalize analytics and AI? The model lifecycle diagram is quite helpful to get a first overview of the tasks we need to cover. You might have seen a picture like this before. It describes the typical steps or phases in the life of your analytical model. Reading from the bottom left, we start with data prep work, followed by model development, model validation, deployment, and retraining if we experience model degradation over time. The right-hand side might be new to you. This is a extension that I always like to add because in our experience, focusing on models alone is not sufficient. Models need to be embedded into business applications to really support decisions, which means, simply said, that you have to take action based on those models. Predictions. And as part of the MLOps platform that SAS offers, SAS Via, We have developed tools that support this, but this will not be our focus for today, because today I want to focus on the task shown in the center. So we're going to talk about model management, model retraining, model monitoring. So let me try to summarize. ModelOps is about improving, streamlining, fastening the process of bringing a model into production. The key here is automation. At the same time, there is a cultural facet to it. Often we tend to think of ModelOps purely in terms of technology and tools, but the reality is that the DevOps idea, ModelOps idea as well, started out as a cultural shift to streamline intergroup communication between developers or data scientists and the operations team. So if the organizational setup is not set up to support this idea, any ops approach will probably fail. And finally, ModelOps is actually a misnomer to some extent, because we very often see that a single model does not fit the bill for real world purposes and use cases. We often see the need to add rules to the models so you can automatically take actions, and that's what we call decisioning. One typical use case, for example, for ModelOps is in the financial service sector, where hundreds of time series models we have in that case are used to focus on strict rules for bias and auditability. I'd like to point you to an interesting read from some folks at Google. This paper focuses on model testing as part of automating model development and deployment. It describes more than 30 tests for all aspects of your machine learning framework, and it really supports, I think, the case we're trying to make here. In the machine learning space, you should lean on standard processes, learn from software development, where aiming for maximum automation and full test coverage has been a well-established strategy for years. However, we need to take into account that analytical or AI models are different from software. They strongly depend on the data they're working on, and we cannot easily predict how changes in the data will lead to changes in the performance of our model, which means that our tests or your tests need to be much more sophisticated than what a typical software engineering would do. A simple unit test based on a static assertion of an expected outcome, for example, will not work, at least not in over a long period of time. In our use case, I will focus on a few of these tests that I have developed and put together for this use case, and I will show you how they can be run in an automated pipeline. And with that, so I would say, let's start with the use case. I have prepared a little play role. I am alone today, but I will actually be wearing two hats. I will be a data scientist and an IT engineer. The scenario, imagine we have already built a model, and this model is running in production. But through a process that I have created, I got notified on Microsoft Teams that something is not going right with my model. And so I have to understand what I have to do, what actions to take, and most importantly, how. So what are some of the best practices? I apologize in advance. It's going to be intense from an application switching perspective. You're going to see different applications, 3 different applications. So I hope you are able to follow, but I will try to do my best in walking you through the storytelling. So I start from my Microsoft Teams when I get a notification that there is something that a specific threshold violated by a KPI. And in this case, we'll see that we're talking about the misclassification rate. And it says, please take a look to this model. Something is not going right. And so with this introduction scenario in mind, what we'll see in the next steps is that I will go into my model written in a Python language. I will go into my model repository where I have all my projects and all my models into my MLOps environment. And I will decide that I want to retrain this model. And after I retrain this model, I will retrain the model. I will deploy the model to a Git destination. Then will that trigger a CI/CD pipeline that automatically will run some tests. And we're going to see what tests we're talking about, because these are the tests that actually are recommended for a typical or a healthy ModelOps type of scenario. And finally, when the model is in production again, we will validate that the model again is on the threshold. The KPI is now good, and the model is performing as we are expecting. ModelOps is not a one-fit-all approach. So of course, it depends on so many things, as I said before. It's not just a technology. We're going to see one use case in this, and it's going to be technology focused. But again, it's something that it depends on the objectives of the company. What are their strategy? What is their vision? How many models do they have? Because sometimes they only have one model, and that is kind of the thing to monitor and to take care of. They don't have thousands, or sometimes they have hundreds of models. For example, we have customers that have hundreds and hundreds of models running at the same time. So I am the data scientist right now, and I am in my MLOps environment here. This is called Model Manager, and this is my project repository. I can see that I'm working on different types of projects right here. I have 8 total. Some of them are computer vision, some of them are clustering, and some of them are, I already put some of them into production. I also go into my model repository. Here I can see my models that I'm working on. And if I go into the specific model or the specific project that I got notified for, which is a policy claim analysis, I can see that in my project, I'm talking about an XGBoost model in this case, and I can go ahead and see that the assessment indicator that it's not working well is a misclassification rate, which is the one that I've chosen as an assessment criteria, which is, I've put the alert that if it's greater than 28%, to get alerted. So let's suppose that I built this model a little long time ago, and I don't remember exactly what's in it. So, and what are the properties and versions and stuff. So I can go inside and I can see that this is a gradient boosting model built in Python. I have all my score resources that I can have access to, my pickle file and my Python, the score code and other score resources, all my variables, and as well as metadata. And I'm also free to bring in requirements that are additional files, personalized. Like in this case, I have built the file that shows me the libraries that these models needs to have. I can also see that this is the 4th version of my model. So it has been already done some work on it in the past, and this is my 4th version. So we got the notification by the system, but where do these numbers come from? Let's go and check the model, the performance tab. And here I can see that I have my performance report that I have created to my model. And this is where my summary page, I can see that the misclassification rate is higher than the threshold of 28% that I set. And I can also check some other statistics like the lift, the RC curve, Gini index, the KS trend. But I want to focus on one that I have built personalized, which is a feature contribution index. Let me explain what this reads. Basically, the blue area is sort of a confidence range, which can be expected by the variable. And the yellow is the contribution index itself. And every time when this index exceeds the confidence bands, like you can see in this case, I get an alert. And so in this case, as I said, I have decided that I want to retrain this model. And so I go back to my production environment, my development environment, or my development environment is when I built this model, and it's my Jupyter lab, where I have created 2 notebooks, one to retrain the model, and the other one is to register the model. I will also collect all the metadata of info of this model and like different model assessments. Here I have all my metadata files that I want to collect. And I also want to put together finally a zip file. And this zip file will be taken and pushed into my MLOps environment that I showed before. But first, let's run all the cells to retrain the model and collect all the metadata information. Now that I'm running all the cells, I'm expecting to receive the zip file. Here we are. We have created it. And now I open my register model Python notebook. I have some credentials, some libraries that I am to access my environment, my server. And then I just call an API from SAS to register the zip file into my ModelOps environment. And here you can see that we got the new ID for the new retrained model. Now back to Model Manager, I refresh my project page and I will see my new retrained models appearing that is successfully being pushed into my MLOps environment and now is ready for being analyzed and being tested. And again, I can open again my model and I can see what is in it. And I can see that the system automatically created for me all the score resources and everything separated in a way that makes sense and are traceable. I would like to know what are the differences now with these two models, and I would like to compare them and understand and see if something have changed. Things like, for example, if anything has changed in the input variables or how they're being used. And in fact, let's see, and in the input variables, yeah, I can see that one, for example, variable in this case wasn't used. And I can also check other fit statistics to compare my two models. So I'm happy with my model right now. And as a DevOps engineer, I would like to, I can push it to my Git, to my repository. I am right now deploying it. And from here, I will hand it over to the IT person, which is still going to be myself. And switching my hat now, I want to show you what happens in the background. So we retrained the model, but what really happens? So how to make sure that everything went run successfully from an IT and DevOps perspective. So what you see here is the Git repository where we just pushed the model. It was empty, but now that I refreshed, well, you can see that I get the folder for each model and a folder for each version of the model. And in that folder, you can see all the artifacts that are part of this project. This project is actually connected to a pipeline tool. I'm using Tecton in this example. We heard before from them. And Tecton was the purpose to running tests and building our container image. For this use case, I've used just some tests, but of course you can add or use other ones and depending of your corporate standards and policies and or the organization, the policy organizations that we're working for. So the first test here is just a test on the code quality check. I can see the data scientist, if he actually or she actually followed all the steps that are compliant to our company standards for code quality. And it looks like they did. The second test is about which open source libraries the models is depending on, because there may be some that we're not accepting for company standards. And this one looks at it okay as well. So I'm walking you through some of the most important tests that are usually recommended. And finally, we have a test that will be to run just some basic sanity checks to see if we have all we need to build the model runtime container image. I can see that this one has been successfully run as well. So since I have all my tests successfully running, I can go and build a runtime container. If any of these tests would have failed, we would have had to go back to the data scientist person and ask him or her to repeat the exercise because something wasn't right. So the result of this pipeline will be a container image. And with the final step, I'm going to trigger a second tool. a continuous delivery tool. And I'm using Argo CD for my use case. And as you can see here, I already have a model in production and I leave it up to Argo to replace that existing model with a new version that the data scientist just built. The great thing about using container technology for models is that you can easily swipe out those models versions without having any downtime. So this is a rolling update. We're just replacing one model with a new version without having any second of being out of service. This has been completed. And since every model comes with a REST API talking about application integration, we can use a simple built-in user interface like this one to run a few manual checks if everything was correct. This is not required, but it might give us a good feeling about the process. So for example, here I can see it shows me if the model version, so I can really validate if I really put the latest version or not, or maybe I try to wrongly put a different version of the model, and that could cause a lot of costs. And quite a nice option is to trigger a manual execution of the model. So we are running a score. I'm running a scoring here. And this is always a best practice recommended, just to do a running score and do a prediction, sending in some sampling data and expect that my model returns some results, hopefully. And that will be my proof as an IT that my task is completed. And I've successfully replaced the model in production. Everything is running as it should be. And I can see that in this case, it worked. And with that, I'm going to hand it over back to the data scientist for the last minute of, let's see what's going on. Let's see if the misclassification rate actually is now in the threshold. I can go back to my performance reports and my MLOps environment where I control everything. I can go into my models and select that now I want to have a performance report on the second model that I just retrained. And I can either run my performance report from here or schedule a job execution to do that. And now we have, let's run the performance report. And we have two summary sections now. From one side, we have the old misclassification rate, the 30% almost. And we can see that the misclassification rate of the new model is now below the threshold. We have now below the 28% rate. So I would say that we were successful here. So I hope you enjoyed this short demo. It was really to show you what happens behind the scenes. I've concluded my use case walkthrough. I'm just going to wrap up this session with 4 best practices that I would like you to keep in mind when getting started with ModelOps. The first thing is think deployment first. As you begin, this is not the last thing you should be thinking about. It's not about, oh yeah, let's explore, let's see, and then let's think about deployment. No, operationalization shouldn't be an afterthought. Build a robust model management and monitoring capabilities first. Next is to connect model metrics to business KPIs. That is so important. The purpose of putting model into production is to generate business value. So not just building models with the highest percentage of accuracy. Think about how your models are impacting the business. Are you increasing the time to a customer action? If your first draft of the model has 88% accuracy, improving that accuracy to 95 can save time, which equates to millions of dollars. A customer I work with uses logistics models for where, when, and how to roll trucks. And their cumulative saving through improved model development is around $200 million per year. Third is implement an end-to-end analytic lifecycle. ModelOps isn't just about retraining existing models. We saw in this use case one scenario where I decided for simplicity to retrain it, but there are times we need to consider new models, new techniques, or even new data sets, new data, because the situation has changed. Think about COVID, people trying to predict their supply chain with COVID. Nothing was right because the data and the external environment had completely changed. And so you need an efficient way to explore those options and incorporate it into a workflow. And last but not least, strive for consistency, accuracy, and trust. One of the overarching goals of ModelOps is to scale the deployment of the models throughout the business. And by doing this consistently and accurately, you will ultimately build confidence and trust in the value of machine learning and artificial intelligence. So I know that we only have 30 minutes today. I want to thank you all for joining me for this session, and I want to have some times for Q&A, but if we, I'm